Alrighty, everybody. So we're gonna talk about game architecture. When you start game development, if whether that's in Unreal or Unity or Godot or whatever, um, there's a lot of your first few projects are probably going to end up being a lot of game objects. I'm a Unity developer, so I'm going to be talking in the frame of Unity and showing examples in the frame of Unity. But if you're in Unreal, a lot of actors, a whole bunch of things randomly talking to each other, right? And you have a billion scripts and they're all on different game objects or different actors in Unreal, and they all have different references to each other, and they're all just kind of interconnected in a big old web or pile of spaghetti, and you just barely make it work, right? It's you wrap a lot of null checks around things. You double check to make sure everything is set up, and triple check and quadruple check, and you should always do that, of course. But there are some ways to there are practices for if you were to architect your game and really think about the layout of your code bases, of your design, of how you built it, to make some of that anxiety of like, oh, but what if I do this specific combination of actions? Will I get a null ref here? Those kind of things can be eased if you actually think about the architecture of your game. Now, in prepping for this, let me put this caveat at the start of this. This is how I do things. I would encourage anybody who's like, I see a problem with that, or I have a better idea on how to approach this. Drop a comment, talk to me about it, because I'm always open to hearing new, better ways, or being told that my ways are shit. So I Googled in preparation for this, because this was actually a lecture for Bradley students where I teach. And I found this, I don't remember where. So if you see this and you said this, I'm stealing your quote. I'll definitely source you in the bottom over here if you call me out on it. Be like, hey, that's my quote. It's a very good quote. What is good code? For what I found online was, for me, good design means that when I make a change, it is as if the entire program was crafted in anticipation of it. Now, every programmer watching this is probably like, if I change my code, it's gonna die, I'm gonna have bugs, and I'm not gonna be able to test it all. The idea is you make code that doesn't run into that issue, right? Being able to solve a task with just a few function calls that slot perfectly, leaving not the slightest ripple on the placid surface of the code. So basically, if I pull one string in my spaghetti code, it's probably going to unravel, or I'm not going to be able to pull it because it gets caught, right? Good code, ideally, is able to be changed. Before we can get into like the general architecture of how I do things personally, we got to talk about a certain set of tools. And the first one is going to trigger a lot of people. I already know it. But hear me out. We'll go through it and we'll talk about it. Or I'm sorry, the second one. We have to go through a couple concepts here. Statics, singletons, dictionaries, kind of. I'll touch on it a little bit. Coroutines and async, managers, services, and controllers. Okay. This is how I break down my code. Okay. I talk statics and singletons is kind of like my core, like grounding force. Then I get into coroutines and async, manager services, controllers, dictionaries. Again, this was mostly this is a repurpose of a lecture for my Bradley students. So if you're like, why is dictionaries doesn't feel like it should fit in there, it's because I wanted to make sure everybody was aware of what they are. We'll use an example of how you can use dictionaries really well later. So talking about first statics, I'm going to go over to some code just in case this is something new to you. I'm going to make some new code, call it a static example. And the reason that we're going to get into just basic statics first is because in order to understand singletons, you have to understand statics. All right. So what a static simply means is this is a instance of an object that is universal to the rest of my program. So what that like in action actually means is I don't need a direct reference to be able to get the value of that object. So for example, if I were to say, let me make one more script real quick. I'm going to make a read static script and I'm just going to make read value script because we're not going to simply do statics. if I were to do a variable in my static script, I'm just going to make a simple one. Public int number. Easy, right? If I wanted to, in my read value script, let me make this a little bit bigger for us. In my read value script, read number, like get this and print it out, I would need a reference to the static example, right? Static example, my reference to static example. Make sense? And then in start, I'm going to just go ahead and I'm going to say print my reference to static example. Sorry, my reference to static example dot number. That's going to print out my number. If I go back over to Unity, let's make some empty game objects so we can actually run this and see what's cooking here. So this will be static example, and then this will be read value script. So let's put these scripts on, read value script, static example, easy peasy. If I go and give static example to my reference to static example here, there we go. I'm going to make the number a great number, 7. And if I go to the console, this will print it out, right? When I hit play. Should be easy. Now, in games, let's take it, and again, obviously this is in Unity. This applies to all kinds of games and all kinds of tools. If I use Unity, or I'm sorry, if I use Unity's scenes, and for example, let's say I carry this game object to different scenes, it's going to lose my reference to static example, right? Not ideal. What I can do though is, or let's just say that like, for some reason the reference gets null. The example I'm about to do might not work if you actually change scenes, but the idea is I might not necessarily be able to, in my game, just be able to drag that reference in, right? There are times where, like, especially if you spawn things in, or if you do something, if you're actually making a game and not just doing a silly little example, there are times where you can't just drag this example in. What you can do instead is make this number static. And you'll notice immediately I'm going to get an error over here because I no longer need the reference to my reference to static example. All I need to do is say static example dot number. Now, you'll also notice in Unity, Unity does not serialize static variables, right? So I can't just go ahead and set that. I can, however, go ahead and set it in start. Now, interesting thing, I have 2 start functions. Unity randomly picks which one happens first, okay? They're both in the scene. They both are going to go. It's a kind of a guess on which one will actually, will this start happen first or this start happen first? We're going to talk about that later. So what I'm going to do instead is I'm going to say if input.getKeyDown keycode.space, and then I'm going to print this. Just so that way then I don't have to worry about the start thing happening on me, right? I don't want to have to trust that. But on start, number is going to equal 10. And when I press spacebar, I'm going to go access that static variable. Okay. Bam. Prints out 10, right? Works great. I never use this. I wanted to get the idea of what a static is. It is basically a variable that is floating out in the ether, right? It's just floating out in your game. I do use statics, but I never personally use them for a single variable. I feel like there's just too much, that's giving too much power to something too small. And I'm sure there are people who will be like, no, what I'm about to suggest you do is wasting memory or something like that. And they're probably valid, right? Just in my projects and my personal experience, I've always found it easier to make entire classes static have them kind of roam around in my game and be there at any given time with important information. Because there is a philosophy, and it's a good one. This one I think is kind of like nobody would argue with, that code should do a single thing, right? Um, and I think that is a very subjective, like what that thing is. For example, we're going to be talking right now. We're going to kind of like bridge the singletons and managers section together. Um, a game manager should do one single thing. I couldn't tell you what that one single thing is, other than control the game. Um, Theoretically, you could write your entire game in a game manager. I wouldn't recommend it, but you would technically still be following the rule. It manages the game. That would be pretty much every part of the game, right? Don't do that. Really kind of like nail down what you want your game manager to do. But you can make managers static. So, with the power of singletons, okay? Because the thing is, if we were to make a game manager and we were to make it static, so it's floating out into the ether, and I know I'm talking like concepts here, so don't worry about the code right now, and somehow there were to be another game manager get introduced. Maybe you reload the scene and there's a game manager, or you reload the level and the game manager is in the level at start. Well, then because it's static, you'd end up having two, right? Because statics just float around, right? Or if there was just somehow that you managed to get two in the same scene, would not be ideal. Because when something goes to try and call on that static variable, they're not going to know which one to get. So we do something called a singleton. And I remember when I learned about singletons, I was like, but there's no singleton keyword. There's no like, we have update, we have start. There's no such thing as singleton. And you're right, there isn't. It is a code practice. We went a little too far. You guys saw Patrick already. There's a code practice called the singleton pattern. It's a very common code pattern that basically ensures that there's only ever one instance of a static class. Because if I were to have, for example, we're going to go ahead and make our game manager now. Game manager. And we could just talk about it. You can really think about it if you've ever had a job and there were too many managers, too many like cooks in the kitchen with like upper management, and like one tells you one thing, the other tells you another thing. It's never a good situation, right? I'm going to go ahead and put my game manager on both of these. And if I wanted to get let's try that actually again. Public static int number again. I'm going to do number again equals random.range 0 to 100. Print number again. Again, I never use static variables, so I honestly am not entirely sure what's going to happen right here. Did I do this in play mode? I sure did. There we go. All right, so let's see what happens. I have two static numbers because I have two game managers. What's it going to print? I get two different numbers, right? Now, if I go over, let's go back to my read value script and say I want to go to game manager and print its what did we call it? Number again. Which one is it going to print? I couldn't tell you because there's two of them, right? There's two static variables on game manager. I have two of them here. We know at start I'm going to have 43 and 16. If I clear it and then press spacebar, I got 16. But why didn't I get 43? I just said game manager dot number, right? You generally want to make sure you only have one instance of these guys. So how do we make that happen? Well, I'm gonna not make this static because if it's in a static class, it can be assumed that it's accessible through like the same methods we're doing. What I'm gonna do is say public static. So I guess I lied. I do use static variables, but I make a static instance of my game manager. Okay. What this does is it basically says I am going to make a brand new version of this game manager and make it accessible to everything. Why did I call it instance? You'll notice that a lot of people who talk about singletons do call their manager or their service or whatever instance. It's just a convention. You can name it whatever you want. But what we do is we say if instance equals null, because this, we just declared a variable up there, right? We didn't actually use it. We didn't actually set it equal to anything. This is where we say instance equals this. And then else, we say destroy. In Unity, we would destroy the game object, okay? In other programs, you might do it a little bit differently, but I destroy the game object, and yeah, that's it, actually. Now, in Unity, let's say you have a multi-scene game, and there's like, you have 3 or 4 different scenes that you're jumping to, right? You then, if you want your game manager to stick around, you can say, don't destroy, unload this game object, okay? So this will ensure that, hey, if there already isn't a game manager called instance in the scene, then we become it. And we tell ourselves, we mark ourselves as don't destroy, unload, so we're here throughout the entire game. Generally, I load these on my, like, title screen or something like that, so that way then they're up, they're prepped, they're good to go, and ready for when the game actually starts, right? Otherwise, we destroy ourselves because we shouldn't be here. There's already a manager here. Too many cooks in the kitchen is going to cause problems. So, if we go back over to Unity, oh, I got an error. Yep, because we got rid of that, right? We'll come back to that in just a second. But we'll notice that my game manager, I have 2. It has its variable here, so I can mess with that if I want. But if I hit play, it will delete, oh, it went into the don't destroy, unload, one of them. And it doesn't really matter which one, right? Because we ideally have made this a prefab, we've edited it, you know, however we want, all that good stuff. But that is the power of a singleton. Now, well, I kind of like, we've touched on the power of a singleton. There's one game manager, it's the only one here. But we didn't really show how, like, everything on it's accessible, right? So if I go and let's say I have a public string pool name and public float best number, you know, these are really important game information, right? If I go over to my read value script, I can now say, well, I want a game manager, and I know I have one floating around called instance, and I can get that information off of it because I know there's only one. It's like when you have a good manager, you know, you can call them whenever you need if there's something going on at the shop. What was it? Cool name and best number. I tend to call them that. You know, I know for a fact, because that singleton was set up, that I can go ahead and do this because I know these things exist. It's kind of like a rule in your code at this point, unless you go destroy your game manager. This is where your architecture comes in, right? Now, we have all this going. If I go over to my console, let me give it actually some info. Oh, this is play mode. Let me delete one of these. We've seen a singleton in action now. I don't really want to. Ideally, it should never have to destroy anything, right? But, you know, we want to Z. Ideally, like, you can have more game managers in the scene, but you don't really want to be destroying things if it doesn't have to. When I press spacebar, I didn't need a direct reference to it. You can see read value script doesn't have a direct reference to my game manager, right? And that's really powerful because, to be honest, the read value script doesn't really need to know about the stuff on game manager, right? It just needs to know that it's there and be good to go. Now, that actually brings me to something else. We're going to go a little bit out of order. Well, actually, maybe not. We talked about singletons, and the next thing was abstraction and decoupling, right? So, anybody who's used the new input system in Unity knows how actions work. The previous input system kind of went and said, in update, which is run every frame, we're going to go and we're going to check to make sure, see if a button has been pressed. And a lot of people's code was a lot of if statements and checking these things. The new input system simply says when a button is pushed, an action is invoked, and it screams it out to your code, right? It just yells it out and it says, hey, whoever's listening, do this thing. Those actions, if that was your first introduction, I'm looking at my students right now, to the idea of actions and events, is not limited to the input system. And is actually a really good way of formatting your code so you don't have a bunch of single references on a game object. If your script has like a giant list of things in the inspector that you're dragging in there or making sure gets assigned, there's generally a better way to do it. And that's with, I'm going to say actions. Events, Unity actions, they all pretty much work the same. They're just different flavors of the same thing. I'm going to show you the one I use, and I think it's really, really powerful. So what I'm going to do is say public action, and you'll notice that it added my Visual Studio loves me. So it added the using system up at the top. And I'm going to say space bar pressed. And actually, I'm going to make it static. Okay? Now, in my spacebar press, I'm going to get rid of these prints because I don't think we really need them now. I'm going to say spacebar pressed. I'm not going to call it like a function. I'm going to say invoke. All right? This basically means scream out your action. Say that this thing happened, right? It's very similar. I know right here, this is actually the old input system, right? I didn't have time to set up the new one. And if you want to look at how to set up the new one, you can go check out my YouTube video in the Brick Breaker tutorials, or any of the other videos on YouTube about how to set up a new input system. But for quick, like just examples, this is really useful. Now, I'm going to make a new script, or I could do it in the static example. Let's say I have a function here. We'll delete this. We'll say public void handle space bar, and that's going to print out, yo, I handled space bar press. Really good. All right, so if I'm going to say because this is static, I don't need a reference to it. So I guess I've lied twice now. I do use static variables, but I do use them for mostly instances of a class. So I can have like a reference to like an entire class or actions. Okay, you can do actions non-static, but I just feel like it's a little bit easier when you make them static. And I again, well, like I said at the beginning, any programmers out there who wants to call me out and say the dangers of this, by all means, please do. But I think if you manage your things correctly, you could generally avoid any dangers. But what I'm going to do now is say read values script dot spacebar press. And if you use the new input system, this should look familiar. Plus equals handle spacebar press. What this is essentially doing is saying, I will do handle spacebar pressed when this action is invoked, when I hear it, right? It's basically giving this code a set of ears, exactly like the new input system works with the dot started, dot canceled, dot performed, if you know what I'm talking about. The thing that we're doing here, though, is an action that I made. Let's say I had a collision, or let's say I have a function that gets called on here. I can now just send this out and it goes, right? Or let's say I shot a gun, right? And I had another, this was the shooting code. This was something taking care of my sound effects, right? It could play my sound effects, not just print out, yo, I handled spacebar pressed, right? Now let's go see this in action real quick. That's Patrick again. That's not what I wanted. So I think that was in our, well, I'm just clicking all over the place. That was in our read value script static example. I just want to make sure that they're both in the scene. Read value script static example. Perfect. Now, there is a danger with this stuff though. If I press that, there we go. We did spacebar. Now, and any of my students who are watching should know what I'm about to say. if you, let's say we're not using start. Let's say somehow, for some other reason, we have our thing in on enable. I just want to show this real quick. The read value, spacebar pressed, and all that stuff. This does not go away when the object does most of the time. Okay. So if I do this and press spacebar, believe that was in what script? Our static example. If I turn this off and turn this back on enable happened again, right? So when I press this, now it will have read 2 times. This happens, these references carry over. Also, if you like switch scenes and come back, it will still be there unless you get rid of it. These are things that just persist throughout your game. So whenever, and this is true for, I actually did some testing yesterday. I don't think it's true for the new input system, but it's still a good habit to get into. If we do a subscription like this, it's just like your Netflix subscription, right? You want to on disable or on destroy. Both happen when you load a scene. Both happen when you are disposing of an object. We want to unsubscribe. Now, once you get into more code architecture, generally you'll have something like a start that you wrote and a destroy that you wrote. You would put those in there, right? You do your subscriptions and you do your unsubscribe. For me, I generally call them initialize object or service initialization or some kind of function I'll show you guys in a little bit, and then a dispose function. And this is simply where you're going to say, I'm subscribed, and then I'm unsubscribed, okay? So now, if I go and do that, I'm going to get subscribed right at start. It happened. So when I press spacebar, I'm good. When I turn this off, it unsubscribes. When I turn it back on, unless I'm full of it, you're only subscribed once. It maintains a single subscription. It would suck if you're subscribed to Netflix and every month when it came back around to charge you, you got a new subscription. And then you ended up paying twice or 3 times or 4 times, as time goes on. So you want to have that kind of like puppet master control over your game. Now, I'm going to pause the recording for a second, so you're going to see a little, probably, while I open up a project where this is done at a much grander scale. So, a better, a larger example of this, and this is using the new input system, like as an example, but I just want to get like the point across of you don't necessarily always do this in start and in enable, right? So, if you've been in one of my classes before, you've heard this example of the new input system is really great for if you have a multiple different control schemes. Like you're playing a third-person shooter and you can get into a car and then you can get into a plane. That right there, the running around as a third-person shooter, car and plane all have different control schemes, right? In my game that I'm working on, Path of Progress, it has gameplay controls, menu controls, hub controls, right? So what I do is when I enable a new set of controls, I have a disable for other controls. So for example, when I enter the hub, my menu controls are all unsubscribed. And my gameplay controls are all unsubscribed because I don't want to be able to attack or move. Well, move has its own thing for the hub controls because obviously you could still move around in there. But again, this is just another example of as you build more code architecture, you're not going to always want to rely on start, on enable, or on disable. Especially because, as I mentioned earlier, start starts randomly. If you have like 10 game objects in your scene, you do not know which game object is going to run start first. Unity picks at random. So how do we fix that? Because you've probably run into a very common bug called race conditions. And especially if you start getting into web dev or stuff like that, or online multiplayer, race conditions become probably the bane of your existence, unless you've architected your code correctly. I want to, again, stress the idea of managers, and I'm going to, go under the hood a little bit with my game Path of Progress here, just to give an idea of how I handle this situation. Let me go to the testing scene that I'm working in mostly. You can ignore all this garbage, but the way that I go about setting things up, and it's something I picked up at a previous job that I worked at, um, is the idea of having a set hierarchy of managers. Okay. And those managers all have different services that they're responsible for. Now, this again is, like I said earlier, there are dangers to statics and stuff like that. You can definitely become over reliant on it. I know I have in this project at times. And then that's time for a refactor and whatnot. But while you're building, while you're prototyping, you're gonna have that. So don't feel like, oh, if I do this now, I'm not gonna be able to go back and change it. You absolutely will. But the process that I go about doing things is, if there is a set of functions that all fall under the same umbrella, they are universally important. Let's take audio, for example. Audio is going to be something that's going to be touched by everything, right? I'm going to generally have a manager for it. And it came to my attention that, like, some managers relied on other managers to be made first. And if I just do everything in start, I can't rely on all the managers being built in the order that I wanted. So I went ahead and I made something called my application manager. And this is where we're going to introduce one more new topic called tasks. Now, if you've used coroutines, they are very similar. And actually, the first time I did this, I did do it all through coroutines. Okay, so if I go through this task thing, if you understand the logic but you don't like the syntax, you can use coroutines, though tasks are more performant as far as I'm aware. When you get into like performance stuff, that's where my knowledge kind of like fades a little bit, when you get into like the specific milliseconds and how they work at like their core machine level. But as far as my research is done, tasks are generally more performant, and I know they're used more in web dev. So it's good to be getting used to using them. But essentially I have a system that says, hey, the application manager comes in, spawns in my gameplay manager, because that's like one of the most important managers. The gameplay manager does all its setup, and then after, because of how tasks works, which we'll get into in a second, it waits for gameplay manager to get everything it needs done. And then it goes to camera manager, and then it waits for everything for camera manager to get everything done, and then input manager. If you've ever seen a load bar and it's finishing up all those different steps and you're like, whoa, what is it all doing? Sometimes devs like make it funny, right? Like releasing the Kraken or something like that. It's going to go through each bit, and then when it's done, application manager will be told that, hey, all the managers did all their things and we're done spawning in managers, right? So let's go into the actual like nuts and bolts of how that's working. There's our, our wonderful singleton, and you'll notice that I have an async operation. That's what this is called. Async simply means that, let's see what it says when we hover over. It doesn't say anything when we hover over. I'm going to pause for a second so I can make sure I get this definition right. So an async method runs synchronously until it reaches its first await expression, at which point the method is suspended until the awaited task is complete. So what that's essentially saying for our, here we go, awake is awake will not finish until our initialize app is finished, okay? And the same thing here. Our initialize app will not finish until the because it's in a for loop, all of our managers have finished their init functions. And this, it's like a rabbit hole, because our init function will not finish until the service initializer is finished. And the service initializer will not finish until all of its services. You can think of it as like a tree. We have our manager, and then we go, and it has services, and each one of those must complete. It reports back up to the manager and says, yep, all your services are done. And then it reports back up to the application manager, kind of like the big Kickstarter, to say, okay, cool, I'm done. Let's spawn in the next manager. This await means I cannot do in this for loop another iteration of the for loop until this manager that I spawned finishes setting what it needs to set up. Okay, now we do that by using a task, and this is where it comes into like the coroutine like equivalent, because if I just delete the task, an async operation it has to return something. So if I do void, that's cool, it'll work, but it won't be awaitable. An awaitable needs to, I believe, it has to await a task. Okay, and because tasks, if I go here and say return task dot completed task, I will get an error. Why? That returns task or team core word may not be by an object. Oh, I think it just auto is going to return that. So you don't actually have to use the return keyword. I admittedly have not used tasks much beyond this simple situation here of like waiting for things to set up and then get done. But when the task is returned under the hood that it is completed, we'll go and we'll finish the rest of this code, which is simply saying destroy it. Honestly, looking at this right now, this should probably be out here, right? But yeah, so that's what a task is essentially for. And what this ensures is your order of operations will always happen in the order that you want, okay? And that, I believe, let's go back over to our presentation, if I can find it. Here we go. Let's get this going again. The big thing with this is the services and the manager and Singleton does kind of fly in the face of object-oriented programming. They're no longer just relying on a single object. You're relying on something that's just floating in your game. Though they, in my game, they are objects in the inspector, it's not really the same thing as object-oriented programming. And this is like the big caveat to it. The action situation that we were talking about, how like you're having things listen for these actions, is what we call the observer pattern. It is, again, kind of sort of taking a step away from object-oriented programming because you're not throwing over an action to it. That actually did just remind me, I wanted to show one more thing about action. So sorry for the jumping around here. We're going to go back to the action situation here. You can pass information, I think 16 variables with it. Yeah, you can pass a lot of different things with your action. So if I do 5 and 5.5, right? The only thing then is the option, the function that handles it then needs to take those variables, right? So actions aren't just to screen. You can send information. If you've used the input system, that callback context is the information you're sending over. That's if we go back over to our input manager here, all of these guys have the callback context because that action that is being fired off has is sending that information over. And this actually just reminded me of another thing. I knew I was forgetting stuff with actions. You will get an error if nothing is subscribed to your actions. So let's go back over. Here we go. So if I run this, right now I commented out being that thing subscribing and I get a null reference. And that's because it screamed out and nobody was there to hear it and it gets mad. So what we do in order to like appease that is we use, I'm blanking on the name of it, the question mark operator. It essentially verifies that something is there to actually listen for this. So now, basically, you just always put that there. You always, when you go to invoke an event, you do the question mark operator to ensure, I think it's the ternary operator? I might be wrong with that. I feel like that's what it's called. But it is to ensure that there is a, see, I'm getting no error now, something actually listened to it. The event doesn't go and fire off if there is nothing subscribed to it. So now if I go uncomment that out, it will work exactly the same. So in closing with this, the power of singletons, the power which comes from the power of statics, allows you to have things just floating around, right? I have this game manager. If I were to go to another scene, because I marked it don't destroy unload, it's still going to be there. If it had important information like where I was saving my game, or where the how many lives I have, or I just had information that I wanted to carry through scenes, be a good option, right? Though if I wanted to have my saving in game personally, because of that idea of one code doing one thing, I'd likely make a JSON manager that follows the same thing. You'll notice in my game over here, when I hit play, and this is going to make some people cringe, I know, I have quite a few different managers that are spawned in that control various things. And they spawn in various things that they control, right? These are all static. They all carry over from scene to scene. And they're just useful information. Me partitioning out my code so that way then the, I don't know, let's look. Let's look at, my input manager has a service for aiming, attacking, dashing, moving, and super. And because those are just some of the controls in my game, right? And they're only taking care of what happens with those inputs, instead of having one big old long player controller script, right? So if I see a bug with my movement, I just go mess around with the move controller. If I see or the move service. If I see a problem with my or I need to change how my attack works, I just go change in the attack service. It helps you like partition out your code a little bit. So there's your statics and your singletons. With the power of actions, I don't have to have direct references to every game object, and I don't have to have a million public game objects or a million get components or find objects of type. I don't need that. And with the power of tasks, setting up my game from the front end at the very start, I don't have to rely, ironically, on start, right? Because again, Unity start just happens randomly. It just picks objects. It might go sequentially in the hierarchy, but if memory serves, it just picks a random one and it does it. And you'll notice, besides this, I get out of update. So I don't have to do, I can use async operations and I can use coroutines instead. I didn't show coroutines in here, but if you, I guess let's just do it because I wanna make everybody use coroutines. This is how you write a coroutine, right? I said in closing and then I just kept talking. Coroutine example. And if you do something silly like while true equals true, yield return null, you just made update. It's that easy. Let's say I wanted to, now you might be thinking like, well then why not just use update? Because you can cache this coroutine. Let me not name it exactly the same. So let's say when I press spacebar, I'm actually gonna, yeah, let's do this. If coroutine example cache, did I spell that right? I must have spelled it wrong up here. Let's just copy it. It does not equal null. I can say coroutine example cache equals, oh, I just realized my face is in the way of that. So sorry about that. There's our oh, is it not even showing my cursor? Not too well there, huh? There's our coroutine, right? Coroutine example cache equals start coroutine example. Coroutine example. Which in this case is going to just constantly invoke our spacebar pressed, right? And I could say else, if it isn't null, because the first time I press spacebar, it's going to set it here, I'm going to say stop coroutine
coroutine example cache, and then set it equal to null. So then next time I press spacebar, it'll start it up again. This, I'm going to take the code over here, go back over to our example here because it's in the read value script. That's not the one I wanted. I want this one. If I press spacebar, oh, whoops, I got my if statement backwards. If it is null, somebody's probably reading this like, yeah, no shit, guy, you wrote that wrong. If it is null, then let's start it. Otherwise, let's stop it. So let's try that one more time. I do that every time I do this. I get it backwards. There we go, and we're printing, and we're going, and we're going. Basically what you would expect with update, with it just like a boolean, and when I press spacebar, it stops because it's stopping the coroutine and setting it equal to null. Now, if I wanted to make it happen less often, I could say yield return new wait for seconds 2. So then it would happen every 2 seconds. It's absolutely fair, absolutely fine. But this is how you can essentially either have an update that, you know, works on your terms, or you can actually give it a condition, not like just while true. So that's basically all this says, is while true, which is always going to happen. You could just give it an actual condition that ends it, right? So I could say, I don't know, int iterations equals 5 while iterations is greater than 0. Then I do iterations minus minus, and then afterwards, when it's all done, we set this to null. So now this would go however many times I want, right? Press spacebar. We're gonna go, it's gonna, oh, I'm still waiting 2 seconds, so give it 5 times. One more, and then it's done, right? But then I can clear it and run it again. So, the power of coroutines, right? You can also do this with tasks, just as easy. But yeah, now I'm done for real. Coroutines, tasks, really powerful tools to get you out of the update loop, not let keep you bound to start, and will continue to like help you develop your games in a way that things don't just randomly break. So if this was useful, leave a like, leave a follow. I'm getting into that YouTuber bit at the end. But thank you for watching, and I hope that this was helpful. And tell me if it wasn't.